Well, good afternoon, everybody. I'll keep my camera off just for the meantime. I'll switch it back on during the question session. So yes, so I'm actually going to present a journal, and this is around EBV and multiple sclerosis, as been alluded to. And here's the paper. It's in the kind of 21st of January edition of Science, and it's titled Longitudinal Analysis Reveals a High Prevalence of Epstein-Barr Virus Associated with Multiple Sclerosis. And this is from groups from Boston with a lot of the authors from Harvard. And it's only been out a couple of months, and it's already been kind of cited and widely kind of tweeted on Twitter, which is where I found this paper. So just by way of background, I think most people know Epstein-Barr virus very well. It's a childhood infection mostly transmitted by saliva, and virus gain entry through the epithelial cells in the oropharynx and then disseminates in the lymphoid system, and it established a persistence in B cells in mostly individual or in all the infected individuals. And quite often, if we see them in kind of young adults and the older people, they tend to cause kind of more prominent symptoms in terms of infectious mononucleosis. And this infection is fairly common with 90% of the people globally infected with EBV. Now, EBV is a fascinating virus from the immunological point of view, and I really kind of encourage people. So this is a link to the Wikipedia website, and I wrote a very interesting case regarding EBV that provide a lot of lessons for learning in around the immunology around EBV, and some of this actually is going to relate to the kind of the mechanism of how we think Epstein-Barr virus causes multiple sclerosis. So I think this audience is much more familiar with multiple sclerosis, so I don't have to spend a lot of time. Essentially, it's thought to be an autoimmune mediated demyelinating disease affecting the central nervous system, and we see them mostly in young adults. The epidemiology seems to, I wouldn't call it very rare, but it is uncommon. So it's estimated about 2.3 million people worldwide have MS. So it's about 1 to 1,000 to 1 in 5,000, depending on the population, is the prevalence of MS. And this could be an underestimate because the presentation is so variable. So, there's this thing about like there are no two cases of MS that are identical. They present in various kind of sensory and motor deficits. And in terms of disease progression, they can also vary quite widely. I mean, there's the kind of the episodic form, and there's the remitting and relaxing form, and then there's the progressive form, but all of which does suggest that in the long term, it is a chronic illness, and it does progress over time. There are many kind of biological factors that have already been found associated with MS. So genetic or environmental and infectious, and particularly EBV has been long thought to have a critical role in the pathogenesis of MS. And this is particularly true for people with infectious mononucleosis. The association there has been established and is thought to be fairly strong. But of course, we know that association doesn't equal causation. So what is it that we still need study to establish in terms of the EBV as the etiological agent in MS? So the one aspect is strength. So this is the kind of major aspect. We need to know how strong the association is. And other issues such as consistency, specificity, biological plausibility, these are all things that we have to consider in the causative criteria. And I think this paper goes a long way in addressing some of these. But the most important part, and this is why I chose this paper, is for the kind of temporal sequence of things. So the key thing of cause and effect is that the cause has to come before the effect. So in this case, one would have to prove that EBV infection occurred before and is initiating this causative pathway that resulted in MS. And I think this is a very interesting kind of epidemiological design that allows us to kind of look at this in greater details. And finally, of course, this is EBV is a very common infection with a relative disease. So you already know that we require a relatively large sample size in order to address the question properly. So how did investigators go about kind of tackling this issue? So what they did is that they have access to this amazing active US military personnel of 10 million strong, and they have longitudinal data between 1993 to 2013, so like 20 years of follow-up data. And these individuals that enrolled in the army that need to have HIV testing done twice a year, it's kind of a bit mind-boggling thinking about it these days, but anyway, most of these samples, well, I don't know how many of those samples were actually saved, but they say they have in their possession about 62 million archived serum from this particular group. And from the prior study, that sample within this cohort, we know that the baseline EBV serology is negative in about 5% of these recruit or personnel. So what the study done is basically they found people with MS within this cohort, and they had this kind of classical nested case control study design, where they found the cases within this cohort, and then they go and found 2 times the match control for each of the cases that I found within the cohort. And these are all cohort of young adult at risk of developing EBV and MS. The paper did say that this particular population is kind of demographically diverse, come from different background and different geographical area. And of course, the longitudinal data will allow them to have some answer if this kind of cause and effect issue that we have mentioned earlier. And from all these serum samples that they have retrieved, so for each of these cases and control, they have chosen 3 samples. So 1 is baseline, and 1 is the closest to MS onset, or for in the cases of controls, the kind of matching time period to the case. And they found a midpoint in between, just so they can have sample in 3 different time points for each of the individuals that's part of this study. So what did they find? So first of all, they looked at serology. So if we look at panel A, what they found is those are the 3 time points that I mentioned earlier. The green is the people with MS, and the blue is the people without MS. And the first thing that you can see is that there is a big difference, particularly at the end or closest to where the development of MS, there's a big difference in seroprevalence in terms of those with and those without. And there's basically 97% in those people with MS, and I think it's like 57% for those without. So there's a 40% difference among those 2 groups. And if you look at the median time from the positive serology to development of MS is about 5 years, and seroconversion probably happened sometime before that. So they estimate that the seroconversion to MS development is about 7.5 years from this. In contrast, they also done CMV serology, and here they see that so first of all, to my surprise, the CMV serology is much, much lower than EBV, first of all, and across all 3 time points. And then, among this group, you can see that there are no difference between people with MS. So CMV in this case is acting as control, which is showing that it's not contributing much to the development of MS. And this is probably the kind of bottom graph is probably the kind of most important take-home message. And that is among the people who have seroconverted. So this is not counting the people who were positive EBV at baseline. The people who converted during their 20 years in the army, they have a hazard ratio of 32 times likely of developing MS compared to those that didn't seroconvert. And if one look at those who are baseline positive, so this is the rest of the EBV serology positive individual, you can find that the hazard ratio is still quite high. It's about 26 times compared to those that are EBV seronegative. And here you can see in the control CMV, it's close to 1. Fascinating that the author actually commenting on this, and they say EBV in this study and apparently another study had positive serology has shown to be protective or slightly protective against MS. So I don't know whether that's some sort of confounding, or it may be the fact that someone infected with CMV may provide some sort of immunological milieu that is kind of somehow protected against MS. We don't know, one can only speculate, but the effect, the important thing is effect size here is much smaller than compared to the effect that EBV has against MS. Now, next, I look at the issue of, the kind of temporal trend, and the important thing is that they have a biomarker which is kind of likely to give us some idea as to whether they can pick up early MS, and this is this neurofilament light chain and in the serum. And they said in the paper, I don't really know this biomarker very well. It's a very sensitive marker, although not specific to MS, that they can be detected up to 6 years prior to the onset of MS in those individuals. And what you can see here is that if you look at before EBV infection and at the time of EBV infection, or close to the time of EBV infection, there is no change in the level, as far as I can see, of these neuroaxonal degeneration biomarkers. But if one look at after EBV infection prior to development of MS, you can see that in a group of MS, these level is a bit higher than those without MS. And to put it on the kind of individual level change, so this is a kind of slightly altered graph here. So if one look at the group with MS, before that they develop EBV infection, and at the time of EBV infection, the neurons stay the same. But there is a 60% increase after the EBV infection in this particular group, whereas those without MS, this level kind of stay more or less the same. So these people, although infected with EBV, somehow did not go on to develop MS, and these kind of neuroaxonal degenerate marker is kind of not, is telling the same story. And they also did like this interesting study looking at the antibody response, and this they use this kind of technique called viral scan. So basically, it's a kind of antiviral proteomic chip. So they have this array that has these viral peptide on all the viruses that we know that affect humans. And then they put the serum of individuals through them to look at, what, among the people in the study, and they're chosen as only a subset, about 30 cases and 30 controls. And they looked at what type of antibody response these people have. And the orange is, the higher in MS, and blue is higher in controls. And as you can see, I mean, some of these have kind of like equal amount, but by far, in people with MS, they have high number of peptide against Epstein-Barr virus in both pre-onset and post-onset symptoms. And the pattern kind of remained more or less the same across the time period. And if one dive deeper into the Epstein-Barr virus specific antigens, one can see that it's mostly the latent antigens, the EBNAs, that they are picking up using this virus scan technique. And this may be suggesting that disease process is not due to kind of lytic infection, but more some sort of latency, EBV latency related kind of phenomenon. All right, so that is basically the crux of the paper. So just to summarize, in terms of the quantitative criteria that I mentioned early on, it's got an inordinately strong risk for EBV infection and MS. This 32-time risk is probably the strongest I have found, compared to the next strongest, which is the kind of homozygosity for HLA-DR16 allele. And if you have this, you only have 3 times the likelihood of developing MS. So, the author's comment is that in order for another factor to confound their finding, it has to be something that also equally strong, or probably twice as strong, and then still that we do not know about them, because most of the other factors they would have captured already in the study. And the study findings fairly consistent because all except one MS patient had positive EBV serology. And I think it's fortunate that they have one patient, because I think we had this problem recently, is when you have 0 patient in the exposure group, you actually can't calculate a hazard ratio. Specificity, the control the control virus CMV and others in this case does not seem to be associated, and the antibody response also suggests the same. And biologically, this is plausible because the study hints at, and there are other papers also recently that talk about the exact molecular mimicry actually relating to the antibody response that related to B cells kind of caused by EBV. And finally, I think the biggest strength of the paper is that they have shown this temporal sequence of EBV infection followed by neuroaxonal degeneration, and that precedes the final MS presentation. So I think there is also a kind of accompanying kind of editorial that are talking about other advances and contextualize what this paper actually seen. And there they pretty unequivocally said that EBV is a necessary cause but not a sufficient cause. In other words, that you always need EBV to kind of trigger the event in order to cause MS, but that itself does not necessarily cause. You need a whole lot of other things. So then the question is, why does the other people that get infected by EBV does not develop MS? And that's a very interesting question that basically need to be addressed by looking at more kind of mechanistically and what exactly is going on in the intermediate pathway. I think age of the infection could be part of it. Genetic predisposition we know already, and then of course there are some other factors, and I'm sure this is where the kind of future study will be focused on. And finally, I just thought that this is quite exciting because it actually opens the door for studying infectious disease and autoimmunity, right? So, it kind of is a proof of concept that the same thing can be done for other autoimmune diseases. And in fact, even for EBV, for years, people suspect that it has something to do with SLE and rheumatoid arthritis. And there already some smaller study that have kind of shown association. I'm sure there will be kind of work to kind of look at in these areas as well. And I guess for discussion is, what implication in terms of diagnosing MS, diagnosing EBV infection in adults, and the kind of treatment for MS, this study kind of results in. And finally, I mean, there are people talking about EBV vaccines, and Moderna jumped on the bandwagon since we're coming out with the mRNA vaccine for EBV. And we'll have to wait and see. I'm personally a bit skeptical as to whether this will actually work, because you have to completely prevent EBV infection and then still make sure those people have high level of antibody that they don't get kind of infected later, which probably might end up being worse. So that's all I have, and I'll hand back to Mark for question.
Thanks very much, Marvin. If you could just stop sharing your screen and then put on your video. A really interesting paper, and thanks for taking us through it. It's fascinating. I mean, I got a couple of questions. The first is, can you remind us, they looked at CMV and didn't find any indicators. Did they look at other herpes viruses? Did they look at HHV6, HHV7, and some of the other gamma herpes viruses?
So they didn't do that in the serology portion. The serology portion, they looked at mainly CMV and EBV, but they did have that VerScan, which is basically looking at antibody direct against virums, and that they probably more expensive. They can only do it in a kind of subset of patient, and there they have all the viruses that we know. So like adenovirus, enterovirus, everything that we know that affects human is on that chip. So they kind of spread the peptide of all these viruses in there, and yeah, from what I can see, that they didn't find any kind of like strong responses in those and against those viral pathogens.
And so, just if you can comment, I see Sean has his hand up. I'll come to you in a second, Sean. I mean, the EBV vaccine, as you say, the Moderna mRNA vaccine isn't really probably what you need. You probably need a mucosal vaccine very early on in life to stop transmission. Do you think there's, where would you put your research money?
The mechanism seems to suggest that, once the virus gets in an established latency, there is a potential for the disease process to continue. So from the point of MS, basically, there are no herpes virus where the vaccine can produce sterilizing infection in the long term that you don't get latent infection subsequently. So I don't want to be sound defeatist, but it seems unlikely that this Moderna vaccine can have lifelong sterilizing immunity that prevent EBV from ever getting in, because it's reasonably infectious and almost everybody's got it. So that's why I don't think that it will have a good chance at stopping MS. And when I spoke to Di, and her comment was quite interesting, is that, because there are some stronger association of MS among people with infectious mononucleosis. And it might be one of these pathways that whether you get it as an adult, the type of response that you mount, more likely to predispose you. And then you can see those hazard ratio among people who are positive at baseline versus people who are positive during their time in the army. There is a difference between those two groups. So if you immunize the young children and make them only infected as young adults, maybe you're even kind of increasing the chance that those infections result in MS. So I don't know, this is all speculation. So I don't know whether vaccine, for this probably is not going to be too helpful, I don't.
Okay, well, it would be good to get Di's views as well, but I have Sipo and Sean's hand up first, I think, and then Sipo. And then perhaps Di, if you'll come and give us some views as well.
Thanks, Marvin. It's really, really cool study. Thanks for showing it to us. I used to think, and I still kind of think, that the only way you can prove causation in medicine is through a randomized controlled trial, but smoking and lung cancer has shown us kind of otherwise. I guess a case control design is really the only way to try and get to addressing this. But still, there's going to be some unmeasured confounding. I'm trying to think about where the sources of that could be. So I've got two questions. I don't know if, you probably won't be able to answer this, but just to think, the first one you might be able to answer. So the first question is, did these guys set out with the hypothesis that EBV could be related to could modify risk for multiple sclerosis, or did they just kind of get lucky and stumble on this and published it because they showed that there was a strong association? And then the second question is, could one potential confounder be behavioral? So is there something about the way that people that got EBV behave that wasn't captured, that is linked to acquiring EBV, that could put them at risk of getting multiple sclerosis? And that's just to get your thoughts on that. Thank you. Yeah,
so for the first one, I think definitely that this is a kind of hypothesis driven, because I can't imagine that the work that they're doing is easy or cheap to try to get these plasma sample from the US Army. And there is previous work by some of the people in the group, but also others, preliminary studies looking at this association in just purely kind of case control cross-sectional design. So I think this is a hypothesis driven, and they're kind of bringing additional newer technologies to try and look at this more comprehensively. And then the next thing about confounding, other than what I already said, is that the whole strength of association takes a lot of away from that. But if you think about if something else is both causing EBV and causing MS, you're probably still wanting to stop the EBV infection or monitor the EBV infection because it is a necessary cause. So it doesn't matter what in the front end actually is causing both of those together, as long as you can prove. And this, I think this paper is kind of almost there. I'm pretty convinced that EBV is like a necessary cause. And
except in that one person that didn't have EBV, right? So
yeah.
It can't be necessary. Yeah.
Well, I mean, so they did argue that there are a number of things that could have gone wrong. So that person might have been misdiagnosed with MS, or there could be one of those rare cases where people infected with EBV but did not develop immune response. I think the latter is probably unlikely, because they will probably just go back and do more serology to prove that, and because that one case is quite weird. But I mean, at least to me, I know that in the real world setting, there's always one. So I think it's like that situation where we're talking about early days when we try to prove HPV cause cervical cancer. Like now we kind of widely accept that it's causing it, but in the early days people say, but it's 99.9%, it's not 100%.
Okay, fantastic. So Sipa?
Oh, no, thanks, Mark, and thank you, Marvin, for this great talk. Just a quick one. I think you answered the first one, I think, with vaccination and how it's probably not going to be quite effective. But maybe just your thoughts on just, it seems as if maybe one would never really prevent infection, but how do you deal with the latency? Because it seems as if it's the byproducts of latency that seem to be the issue rather than the infection, or is it preventing the whole thing from infection to latency? What are your thoughts on that, and how then one deals with these viruses that go into latency that end up causing these long-term effects?
Yeah, it seems that it's quite difficult to prevent both, right? So it's impossible to prevent the second one. So once you get infection, like the virus establishes latency, like in 100% of the people they infect. So that part, it's too late. Like once the virus gets in, it's there. So stay with you forever. But to prevent infection, that's where that kind of discussion I mentioned earlier. It's kind of interesting. It's very difficult to know. I mean, my personal feeling is that knowing that EBV is part of this, maybe allow people to kind of monitor their EBV status as adults a little bit more actively and understand the kind of a risk towards developing MS. And, if the other cofactors and genetic predisposition are all worked out, then you could be in the kind of situation where, in a particular age group, one can have kind of more kind of designated tests to try and identify MS. And I think that in terms of treatment of MS, there are progress. There are like, a number of kind of drugs that's being kind of used to kind of modifying the disease. So maybe, it is worth kind of trying to understand a little bit better so we can diagnose the infection better.
Marvin, do you think this opens up further need for discussion and better look at Epstein-Barr virus and chronic fatigue syndrome?
Yeah, I mean, like I think chronic fatigue syndrome in general kind of has kind of have a little bit more interest these days, and then I'm sure there's going to be a lot of kind of people wanting to understand the immunological basis of some of these. It's not just caused by EBV, but also maybe other viral pathogens.
Okay, so we're nearly time to wrap up, but Di, I don't know whether you wanted to make any comment.
I don't think there's any particular thing. I mean, I do think it's been a groundbreaking finding. The link has been suspected for many years. That's why I'm sure this was a hypothesis-driven investigation. I think what will be key is actually figuring out what the actual molecular mechanism is, that the association, and there are some hints that that it could well be a molecular mimicry, maybe the mechanism. So it may, in terms of management, it may rather be trying to recognize the problem and potentially target the aberrant antibody response early on. That might be the useful sort of management lesson from this.
Okay, thanks very much indeed. So Ladies and gentlemen,